exercise. Let S, D, and R semi-algebra. Show that if R is a ring, then S is a ring. Corollary: the category of R semi-algebras is the category of algebras. If the semi-ring is a ring. Okay, so now another important theorem which is shown as before, theorem of definition. A semi-ring R is idempotent if M plus M equals M for all M in R. Theorem: the category of idempotent semi-rings is the category of the algebra. So this is going from modules or semi-modules to algebras. And now I am prepared to define for you tropical semi-ring, which I haven't defined yet. I have just defined idempotent and B, but I haven't defined what is a tropical semi-ring. I introduced an example which is T, but this is not how to do it. Definition. So we deduce that any B algebra has an order. Definition: tropical semi-ring is a B algebra for which this order is total. So let me recap before for you that T was R union infinity plus mean 0 and infinity. This is a tropical semi-ring, but there are more. For example, and sometimes we call these the tropical natural numbers, but that's not a very good name. So every time that you have here a set with a total order, you can create a tropical semi-ring, and conversely, if you have a tropical semi-ring, you can extract a totally ordered group. There is another one For example, have you heard about Grosvenor basis? So Grosvenor bases are an important tool for computing algebraic varieties, for computing sets of solutions of different algebraic equations. And for Grosvenor bases to work, we need total orders on powers of n. Grosvenor bases are an important tool for computational algebraic geometry, and they need what is called a monomial order. And monomial orders are so they are orders in n to the n that satisfies that they are total orders. 0 is smaller than any e, any I here. And if I is smaller than j, then I plus k is smaller than j plus k for all k. So, one example of monomial order is the lexicographical order or the dictionary order. So, if you take, this is a monoid together with sum and 0, and it has a total order. So, with the help of semi-rings, I can transform this hybrid structure into a semi-ring, which is tropical. So the theory of monomial orders and hence the theory of Grosvenor bases can be reformulated in terms of tropical things. And this hasn't been done. People feel this, but they haven't done it yet. This is the advantage of tropical things, that it gives you an algebraic way to tackle these objects. So just to finish this part, let me give you the theorem between tropical semi-rings and totally ordered moments.
Professor, B greater to A and only if A plus B is equals to B, I know.
Here?
Yeah. Last A plus B is equals to B.
No, I think it's okay because here is the minimum convention. Yeah.
A less or equal to B, if minimum of A, B is equal to A.
Exactly. I am using this the minimum.
Yeah. And what difference does it make?
But it doesn't matter. In the practice, you can choose either this condition or this condition. And it gives you just the reverse order.
Yeah, the maximum.
The maximum, the minimum. And it's just a matter of seeing which convention are you using. But some people use this and some people use this. So there is no homogeneous way to proceed. Because optimization problems, sometimes you want to maximize and sometimes you want to minimize. So, okay, let me finish this part with the theorem, the correspondence theorem. On one hand, let me take totally ordered abelian groups. And on the other hand, let me take tropical semi-rings. So what is this? This is tuple. This is n plus 0 an order, and it satisfies that if A is smaller than B, then A plus C, is smaller than B plus C, or C in N. The point is that if you have a totally abelian ordered abelian group, you can create a tropical thing just by adding infinity and changing the order by minimum. That's all you have to do. So you do like you take m union infinity, you keep your notation plus 0, but you change this sign by your new operation, which is the minimum. And automatically the unit for this new operation is going to be infinity. And how can I come back? If I have a tropical semi-ring, I just need to take away the 0, because the 0 is it corresponds to infinity. So these guys are s plus times 0 and 1, right? So the only problem is that I have different signs for the same thing. But if I take away the 0, this is, and if I change the sum by the order, I reverse this change that I made here, the sign, the order by the plus. Here I take the sum and I reverse and I compute the order like that. I am going to get a totally ordered abelian group. And these procedures are inverse to each other. Now, with this, I have accomplished the first goal, which is to tell you that hybrid structures combining algebra and order just by paying a little price. What is that price? You add a new element and you change the binary relation by a binary operation. You get something from commutative algebra. And if you have something from commutative algebra and you don't like it, you like more order theory, you take away the 0 and transform the operation by the order using that rule, and you can treat this as two different structures. So an abelian object, abelian group. Here, I'm sorry, it should be more. You can treat these tropical semi-rings as a totally ordered abelian group. And you can apply order theory or group theory or monoid theory to this. But here I prefer this language because this language is more robust. You have 200 years of developing of commutative algebra. And this language is relatively new, maybe 100 years. So for example, once you have tropical semi-ring, you can imagine that you have a ring. For example, the real numbers. What can you do from an algebraic point of view with a ring? What is the first construction that we do when we have a ring? For example, I can define matrices. What is a tropical matrix then? For example, if B is my Boolean semi-ring, I can treat this as a ring, for example, R. Maybe I can consider transformations from B3 to B2 as if they were linear spaces. So this is going to be encoded by a tropical matrix. Or for example, maybe I have here the tropical numbers, which are union infinity. And maybe I can pick a tropical matrix. What is this? Can I expect to have the same theory as in linear algebra? Can I expect to have diagonalization of operators, spectral theory, triangularization, diagonalization of matrices? And the second question is, why do I care about that? If the answer is yes or no, and I give you this object, what would be the purpose to study tropical linear algebra? What is another object that we can do with two operations with some product? Polynomials. What would be a tropical polynomial? For example, in one variable, it would be a formal sum of monomials with coefficients and tropical numbers. For example, or maybe multivariated. So remember that this is plus, and this is me. So how do I translate this in usual operations? So this is plus, I take a mean, and I take three positions. This is my first monomial, this is the second monomial, and this is the third. So I have three monomials. Here, times becomes plus. So this monomial is 7 plus, and exponentiation becomes summing 3 times x plus 5y. So this is the first monomial from this polynomial. Then the next one, infinity, is equal to 0, so multiply something by 0, it disappears. And And now, here is minus 7 plus 8x plus times y.
Middle one should be 0.
Sorry?
Infinity.
No, because infinity means that the minimum of something, and infinity is like if it is not here. Because the minimum of something is always less than infinity, so I can erase it. So this polynomial, this is something, if I should write,
What should be right here?
this if I want is in the traditional mathematics. So it is the same thing that this term was not available. But in tropical mathematics, infinity is just as multiplied by 0 in traditional mathematics. Again, if I have this, and if I have this, I can study them. But why? Is there a purpose? Is there an application of these ideas to traditional mathematics, to classical mathematics? And the answer is yes. For example, these kind of things appear in probability theory, in game theory, but I will not discuss that now. What am I saying?
Are we going to convert that matrix to polynomials where triangular forms or all other forms that we have been using or we have been doing?
Yes.
In the
So,
same way,
so the domain of tropical linear algebra in which we study matrices, properties of matrices with entries on the tropical numbers. This is very well developed, but the applications are towards things like optimization and game theory, for example. This has applications in optimization and game theory. So, for example, analogs of linear algebra, of theorems in linear algebra, have their tropical analogs, and these tropical analogs gives you some ideas in this area. But the important thing here is that it is harder to do this with this because if your brain, if your mind sees this, you are not going to be pushed to do this. But on the other hand, if you see one scenario, you see, oh, I have an object which is very similar to the real numbers, to the integer numbers. So your mind, your brain automatically is pushed to do this kind of things. So the purpose of this first talk is that a small change in notation, a small change in presentation of mathematical ideas can lead to new developments. And this is the first step for tropical mathematics, is that if we merge the order and the algebra into a single structure that resembles a ring, and then I read a book and somehow I find that this is related to semi-rings, I can start doing more abstract things, and these abstract things can be applied to other branches of mathematics, like this. So I think this would be everything for today. Thank you.
okay, Professor, thank you so much for the nice talk. If you have any questions, you can ask now, or if you have any further discussion on the topic, you can discuss it, Professor, later on. He's here for the next 2 days. Okay? Thank you so much.